Now here you see a solid cylinder rolling up an inclined plane of angle of inclination 30 degree. So here you see an inclined plane 30 degree. I am naming it as A, B and C, and it has gone up to a height h. Now here a cylinder, and it has gone up to height h. So here there are two type of motion. One is the kinetic. There are two type of motion. One is the rotational motion and another is the translational motion. So here kinetic energy by rotational motion plus kinetic energy by translation motion, this will be equal to mgh, potential energy, because it has gone up to height h. So here, since there is no external force, your energy is conserved, and this is simple here. This is half I omega square plus half m v square, that is equal to mgh. So here you see that moment of inertia of a solid cylinder, that is equal to half m r square. This is the moment of inertia of a solid cylinder, that is equal to half m r square. So this will be half into half m r square, and your omega will be your v by r the whole square plus half m v square is equal to mgh. So here you see that your r square cancel out. This is r, your r square cancel out, and m, if you take m also cancels out. So only there will be 1 by 4 v square plus 1 by 2, that is v square is equal to gh. So this will come out to be 4 LCM, 2 plus 1 plus 2 3, 3 by 4 v square is equal to gh. So here your velocity is given to you, that is 5 into 5 and by 10 into 10, that is equal to h. If you calculate this, you are going to get 1.9 meter. This will be your h. This is a plain question. Energy is conserved because there are two type of motion, rotational as well as translation motion. So, and you know that the moment of inertia of a solid cylinder is half half mr square. You know this, all this you know about it. So it is a simple problem. But when when it is returning down, here we are considering this motion of the center of mass. We are considering the motion of the center of mass when it is returning returns to the bottom. We are considering the center of mass. So here you have learned this in your theory, that the total kinetic energy of total kinetic energy for this rotational and translation motion, you have learned in your theory, that is your total kinetic energy. In when we are calculating total kinetic energy, we consider here total kinetic energy, that will be half mv square plus half I omega square. But here I we are going to take as mk square, where k is the radius of gyration. We are going to consider mi here, mk square. So this is equal to half mv square plus half mk square. This is v com, center of mass, velocity of the center of mass. So m, and here r, that is v com by r radius, that is the whole square, that is equal to mgh. So here you find that here it will be m will cancel out, and if we take half half, this is plus half v center of mass the whole square, this will be 1 plus this will be how much, k square by r square the whole square is equal to gh. Now again, you know that radius of gyration for a solid cylinder, that is equal to r square by 2. Radius of gyration for a solid cylinder, that is r square by 2. So here it comes out to be v the whole square, 1 plus 1 by 2 the whole square is equal to gh. So 1 by 2 v the whole square. This will come out to be 3 by 2 the whole square is equal to gh. So here your 1 by 2 v from the whole square, this will be 9 by 4 into 9 by 4 for 10 into your height h. To the height h, it is at 1.9, so we are taking 1.9. so here this will be v square, that will be equal to how much? 10 into 1.9 into 8 divided by 9. 2 4s are 8, 9. So let me take the help of calculator. So by the help of calculator, I am going to solve this problem. By the help of the calculator, this will be 10 into 1.9 into 8. This comes out to be 152, and 152 divided by 9, this comes out to be 16.88. so let me take the square root of 16.88, it comes to be out to be, so your vcom, center of mass, will come out 4.10. this is your meter per second. So time taken, it has traveled through this AB distance. So we will find out the value of AB. Your sine theta will be equal to AB. Your AB, that is H by AB. So your this will be how much? Sine theta, this sine 30 degree. So AB equal to H by sine 30 degree, and which comes out to be H is your 1.9 into 2, this comes out to be 3.8 meter. So this comes out to be 3.8 meter. So your time taken will be how much? Distance, that is AB 3.8, a velocity is 4.10. so if we calculate it, your 3.8 divided by 4.10, it comes out to be, where is the AB? There is a silly mistake. When I take half V center of mass square common here, what will happen? Here, this is, you have taken, so this square does not comes here. There is no square here. There is no square here, you see. Because I have taken this r square, so there is no square here. So ultimately there is a little bit, I have done a little bit of mistake here. So here it will be how much? Square, that will be 4 into G10 into H is how much? 1.9 divided by your 3. So let me take the help of calculator to find it out. So when I take the help of, let me take the help of calculator. So this is how much? 4 into 10 into 1.9. So this divided by 3, 25.33. So square root of 25.33, it comes out to how much? 5 your V, if you your V center of mass, it comes out to be 5 this is equal to 5.03 meter per second. So your time taken will be 3.8 divided by 5.03. So now let me calculate 3.8 divided by 5.03. This comes out to be T, that is equal to 0.76 second. This is your actual answer. So now let me tell you again. Here, this is a simple question. A solid cylinder rolling up an inclined plane of angle of inclination 30 degree. At the bottom of this, it is center of mass. Center of mass of the cylinder. Center of mass of this is given. How far will the cylinder go up the plane? When it goes up the plane, here the question is a normal question. That is, your energy is conserved. There are two type of motion. One is the rotational motion And another is the translation motion. For rotational motion, it is kinetic energy is I omega square, and this will be equal to half mk mr square, because moment of inertia of a solid cylinder moment of inertia of a solid cylinder moment of inertia of half m r square, and omega v is equal to here omega is equal to v by r square. Your r square cancels out, so this is the height. But when it comes down, then here you see, you have read in your rotational motion that since we are at when we are, because here center of mass of the cylinder is motion of the center of mass of the cylinder is given. So where it is moving down, we take this will be the same equation here, this will be the same equation, that is equal to mgh, this will be the same equation. But the only thing here is that instead of I here, we are going to consider I is equal to mk square, where k is the radius of gyration. We are considering the velocity of the center of mass, of the cylinder, because we are taking the velocity of the center of mass of the cylinder. So here, because here it was the initial speed of it, the cylinder was given here, initially it was given here, so we take the value of this here v, only we kept here v. But here it is given the motion of the center of mass, it is coming down, center of mass means we are going to find out the velocity of center of mass. So in order to find out the center of mass, you have read in your rotational motion, that is the total kinetic energy. When you are going to calculate the total kinetic energy, we are going to consider this I as mk square. Here I as mk square, that is the k is the radius of gyration. We are considering the radius of gyration. When we consider the center of mass, when center of mass comes into existence, when we consider velocity of center of mass, then we take the I is equal to mk square, that is equal to k is the radius of gyration. Now here, if you take half v, your m cancels out. If you take m common here, m cancels out, and if you take here half v square common, so here this will be your result. And we know that radius of gyration for a solid cylinder, this is for solid cylinder, this is equal to r square by 2. So here r square by 2, so this will be equal to how much? You place here 1 by 2, and if you further calculate, you get the velocity of the center of mass is this. Now the time taken to come down, here the time taken to the come down, here it will be how much? That is AB, that is time taken. This is how much? This is AB by v center of mass, center of mass. So your AB is 3.8 and velocity is center of mass is, so this is the time taken to return to the bottom. So the most important point here, that when we are calculating the return motion, here return motion, you are taking the radius of gyration, you are taking, which is given in your textbook, that is the your total kinetic energy when there is rotational as well as translational motion. Then we are taking here radius of gyration. But in this case, it is a plane, because it is moving outward. Your velocity is given to you. It's a plane, it's a velocity is given to you, speed which it is moving upward, it is given to you. So I have here we are taking the simple your velocity is given you to you, because here I have converted everything to v. See here I have converted this to v, because v is given to you. V is given to you. So here I have to take half m r square, because v is given to you, it is given to you. But in this case, here we are considering the motion of the center of mass. So when we consider the motion of the center of mass, we have to take the radius of gyration. The total energy, kinetic energy, will be this. And now by the help of this, you can find the value of time, return time. So, and one of the most important point here is that if you check the time taken to move upward, time taken to move, this is the time taken to move downward, time taken to move upward. If you check it, your AB, this is 3.8 and divided by 5, you get the same result, 0.76 second. You can see, you get the same result. This is very interesting. When it goes up, it is also takes the same result. So this is about this is a question from rotational motion. I have taken this because here two type of condition are existing. In the first, when it is moving up, we are taking only the v, and when we are moving down, we are taking here this vcom. And when we consider vcom, velocity of the center of mass, vcom, that means velocity of the center of mass, then we are taking about this k, radius of gyration. And in when it is moving up, because v is known to us, so we move everything to v, and in here I we have taken solid, that is half mr square cylinder. So this is very important, so I have selected this problem. Now this is all about this problem, and how we have to solve it is given to you.